Hi, my name is Alan Smith, and this webcast is looking at WCF security using basic authentication with Windows user accounts. It's one of a series of Windows Communication Foundation security webcasts on the bloggersguide.net website. It's going to be level 300, so we're going to focus quite a lot on the technical details of security. What we're going to be looking at is configuring basic authentication with Windows Communication Foundation services hosted in Internet Information Server 7. We're going to look at the transport security requirements using SSL, and we're going to be configuring and installing certificates as well as configuring SSL on Windows Internet Information Services 7. We're going to look at overriding the certificate validation. You may need to do that in some scenarios. The scenario is to provide maximum compatibility with clients. So we're going to be using the basic HTTP binding, use basic authentication, and using SSL for transport security. We're going to be authenticating against Windows accounts, which will be local user accounts on the computer that I'm working with. To test the authentication, I've generated a Windows user account called test, and the password is set to test in lowercase for this user account. The service that I'll be using to test the authentication with is the type of project you get when you generate a Windows Communication Foundation service application, and I haven't made any changes to the code really. I've got this service 1 here, and it's just taking in an int value and returning you return this value. The changes that I have made are in the web config file. What I've done here is I've converted the service to run on the basic HTTP binding instead of the wsHttpBinsing binding, which is the default. And we're using this basic HTTP binding to keep compatibility. We want to consume this service with ASMX and with Windows Communication Foundation clients. I've also made a couple of changes to the behavior. I've basically commented out the metadata get. I could comment this in, but I would need to make a couple of changes if I was going to get metadata over HTTPS. And on the client side, I've generated this client test application from this. I've added a service reference and a web reference to this. So I'm testing the ASMX and the service reference there. And I've set up the configuration file in a fairly basic way. I'm not using any security here. In the program, I've got several methods that I'm going to use to call the service, and we'll look at those later. I'm calling it first of all using the WCF and the ASMX client, and these are just regular calls using no authentication mechanism whatsoever. I'm then calling them both using basic authentication, passing test and test as the username and password, which should match. I'm then calling them both just to check that the authentication is working correctly with test and bad, so this should fail the authentication. And looking down at these methods, this is just sort of fairly straightforward call. I do a write with a console colour of what I'm going to call, and then just call it and write out the response. If we get any exceptions, I'm just doing a console write line with the exception message. So this is calling using the WCF client, fairly standard code there. Calling using the ASMX client again is fairly standard. When I call using the authentication, I'm basically switching the basic HTTP binding on to use transport security here, setting the security mode to transport and the client credential type to basic to use a basic authentication, and that will override the setting that I've got here of security mode none in the configuration file, because code always wins over config. I'm then setting the username and the password to whatever was passed in here and attempting to call get data. Again, I'm capturing the exception and writing out the exception message there. Same with the ASMX. What I'm doing here is basically generating a new network credential with username and password, slightly different in the ASMX call. I then do the same thing, calling it with the getData method, passing in 123, and get back the response. Again, handle any exceptions there. So in the client application, I'm just going to F5 this to actually run the code, and we should see the console pop up with the results of what we're calling here. So here we can see both calling with the Windows Communication Foundation client and the ASMX client calling this service. You can get back the results. You entered 123, you entered 123. Now this is interesting. I'm attempting to call the Windows Communication Foundation with a WCF client, and because we're attempting to use transport security and we're using the HTTP protocol, it's throwing an exception. The WCF client is refusing to send the username and password in what is equivalent to plain text over the plain HTTP connection. It needs a secure transport to do that. The ASMX client works fine when it's using basic authentication. It will send username and password in plain text over a regular HTTP channel without secure HTTP though. The WCF client, again, when we send the bad password, it's throwing that exception, and when we call it with the ASMX client with the bad password, we're still getting the service called, and this is expected because we haven't actually turned on any of these security settings. So what I'm going to do now is to convert the service over to using basic authentication here, and there's a few changes that I need to make here. I've already prepared this in the binding file server side. I've got the security mode set to none, so I'm going to comment this out. And I'm going to comment in the configuration in the basic HTTP binding there to actually use transport security and basic authentication. And I'm going to save this web config file. I'm now going to go into IIS and change the authentication for this application. I've got this set up in IIS, and so if I go into the authentication section here, I can actually enable basic authentication for this website. So I click on enable. That is now enabled, and we should have the basic authentication up and running there. I'm just going to do a quick build on the website just to make sure everything gets updated there, and I'm going to F5 on the client again. So we're calling the same method, and we're getting lots of exceptions here from all of the calls. When we're sending this, or when we're attempting to actually call this, we're getting an error here. We've got something in the diagnostics log here. With the ASMX, we're getting errors there, we're getting exceptions there, and we're getting exceptions again. And this is expected here because we haven't actually configured the Windows Communication Foundation to use a secure channel. So we will need to use HTTPS security, we will need to set up a secure channel, and we will need to install a certificate on the server to allow that secure channel to function correctly. So to create the certificate, I'm going to use the make cert command. I'm going to bring up the Visual Studio command prompt. Type in make cert, and we'll see the basic command line options. There are some more advanced command line options which are documented as well that you can use. And it's hard to remember everything to enter here, so what I do is I've just prepared a text file which will have the information in there. So I'm going to go down to the actual projects directory, security, the actual certificate section there, and bring up this create certs.txt. This has got a couple of the command lines in. Now the first thing that I'm going to do is generate a certificate that I can use as basically a fake certificate authority here that I can install on my machine. I'm going to copy this code. I'm going to paste this in here. So we're doing make cert, we're generating a certificate here. This name is going to be root CA test, so this is going to be my certification authority here. And I'm specifying a couple of files here. This is going to be the private key file, and this is going to be the actual certificate file that we are generating here. And when I press enter, it's going to ask me for a password, and I'm just going to enter password here. Confirmation is going to be the same, and I'm going to press OK there. And it's now asking for a certificate for the actual key file, so I'll put in password again, and OK that. Now if we do a dir, we will see that we've got that actual certificate generated, the CER file and the PVK file. So I can actually install this in the certificates panel as a root authority, and I can also generate certificates from that. So to generate a certificate from that root certificate, what I'm going to do is copy this second line of code, which will actually generate and install my certificate that I can use for SSL. So I'm going to paste this in, and we're generating this using the key of test cert, and I'm using this PVK file, the password file there. CN is going to be the same as the host name of my machine here, and that needs to match to get the certificate as being trusted. This is going to be the issuer of the certificate, rootcatest.cer, and it's going to be stored on the local machine under the my section. It's going to be an exchange key. -PE means I can actually export the private key from the certificate if I want to, which is good if we're doing this for testing purposes. And I've got to enter the password again, and that did succeed there. So to confirm that this succeeded, I'm just going to bring up the management console, and I'm going to actually install the, or actually verify that the certificate has been installed. So I'm going to go in, add and remove snap-ins, take the certificate snap-in, add that onto the console root, and it's going to be for the computer account. We want to see all of the ones that are relevant to this computer. Click on next, it's going to be my local computer. Click on finish, click on OK. And so we should be able to go into the personal certificates and see that certificate here. It is issued to this machine, issued by Root CA Test, so that is my certificate provider. So next thing we're going to do is we're going to configure IIS to use SSL and to use this certificate for signing the messages. So in the Internet Explorer Manager, what I'm going to do is firstly go to the default website, and you'll notice that if we look at the actual bindings that we've only got the HTTP binding here. So first thing I need to do in IIS 7 is to go into the bindings section, add on the binding for HTTPS there, and it's choosing the default port of 433, and I'm going to select the certificate that I've just created for this machine here, and click on OK there, and click on close, and you can now see that we've got the HTTPS binding enabled with that certificate for this website. Next thing I need to do is to enable HTTPS on this application. So on this application I'm going to scroll down to the SSL settings, click on this, and I'm going to select that this actual application requires Secure Sockets Layer to actually communicate with this, and click on the apply button there. And that's made that change in Internet Information Services. Now client side, I need to change the actual address at which I'm communicating with the website. So we're going against HTTP, and I'm just going to drop in the S there on both the WCF address and also on the ASMX address. So both of those will now be calling using HTTPS, and I'm going to F5 the application again and see what the result is. Okay, so when we attempt to actually call this, we're using HTTPS, and this is expecting HTTP because I haven't actually changed the configuration file here, and the transport mode is set to none, so that's why that's bugging out. All of the others are bugging out because of this trust relationship. I have not installed my security authority certificate in, so it's basically treating these as untrusted certificates. And working in test environments, you will come up in scenarios where you're using test certificates where you do not have a root CA certificate there, and you will have to override this certificate trust. So in order to see how that all works, I'm going to go into IIS, into HTTP test application, and I'm going to browse this application. I'll just double check that I've got HTTPS enabled on this site. Yep, that requires SSL. So I'm going to right click or go to the content view, and I'm going to browse to this default HTML, and I think it will pop up in using just regular HTTP. So we're getting a server error. I'm going to stick in HTTPS there on the localhost machine. Now this is the error that we're going to get because we do not get a trusted certificate. What I can do is run this from a local machine as well, because this will need to match the issued certificate, and we're still getting this this error here. Now if you're a user, you've got the option of saying continue to this website, which is not recommended. You'll have probably seen this if you're going to sites that do not have a proper trusted certificate, that is just using a test certificate. So if I do this, I get hello SSL coming from that HTML page, and I also get a certificate error, which is the warning in IIS telling me that the certificate is not trusted. It's not been signed by a trusted certificate authority. Now we can do exactly the same thing in a Windows Communication Foundation service or an ASMX service. I'm going to go back to my client code here. I think I'm going to close a few windows here just to make a bit more space. And I'm going to go into the actual client code. I'm going to first of all stop debugging here. Into program.cs, and there's two things that we can do to actually override this certificate. The first thing we need to do is to provide this method here, which is a certificate validation method. Now this typically gets called when we are verifying certificates, and we can actually override the certificate check. And I've put in something here that's a bit unsafe. What I'm doing is just writing out in Magenta that this actual method has been called, and then I'm returning true. That means whatever the sender, whatever the certificate is, whatever information we're getting about the SSL policy, we're just going to accept that anyway, and we're going to accept that certificate. So it's the equivalent of clicking that link on the browser saying I want to accept that certificate and continue. Second thing we need to do is to hook this on using the actual class that we've got here. So I'm going to comment in this line of code. And we're using the system.net service point manager, hooking onto the server certificate validation callback, and just generating a link onto that method here for that remote certificate validation callback. So that is overriding the checks that we've got in the application. Now for F5 again, you can see that these two are failing, but basically because we haven't actually gone across the SSL transport here. We haven't actually provided authentication. But when I attempt to use the WCF service, you can see that certificate validation has been called. We now trust the certificate, and I'm getting you entered 123, you entered 123, and this is calling with the WCF and the ASMX client with test and test as a username and password. If we pass in a bad password here on that user account, we're getting the unauthorized account here, so it isn't letting us log on with a bad password. So we can see that the security validation is working there because we have done this certificate validation override. So in some scenarios, you may not want to do this certificate validation override. What I'm going to do here is actually look at the certificate that I've generated here. If I F5 on here. Apparently I didn't switch directories when I was generating this, so I generated it in the Visual Studio VC directory, which wasn't too clever. But at least I know where that certificate is. What I can do is actually load up that root ca test.cer in here. So I'm going to copy this path. I'm going to go into my certificates console, and I'm going to look at the trusted root certificate authorities here and click on this. So we've got the sort of regular certificate authorities here, and I'm actually going to add my certificate here, or import my certificate. Click on the next button. I'm going to browse down to that location, paste in the path, and we can see we've got my root ca test.cer. Going to click on open there, click on next, place it in the following store, root certificate authorities, click on next and click on finish, and the input was successful there, and you can see this is appearing here. Now this certificate, I'm basically generating my own root authority here, and it will need to be present on the machines where the server and where the client is operating, especially the client, because the client will need to trust the certificate there. So I'm going to go back to my client code. I'm going to comment out this service point manager call, so this is not going to actually do this false validation on the certificate, and I'm going to F5 again and see if this works. So it is working now. We are trusting the certificate, which is saying you entered 123, you entered 123, and this is working from both the Windows Communication Foundation and from the ASMX client going against this service. So just a recap on these certificates. If you want to have this working without overriding the certificate, you can generate your own root ca test using the command line that I use there. Specify the username and the password, and then install this on the actual trusted root certificate authorities. Sorry, that should be just enter the actual password that you're going to use. Install this in the root certificate authorities. You can then run the second command line to actually generate and install this certificate. And then you can configure IIS. I'm doing this in IIS 7, but it is fairly similar, just slightly different in IIS 6 to get this working. And then just a recap on the security. On the server side, using the basic HTTP binding. If I bring up the server code in the web.config, I'm switching from security mode none to security mode transport, specifying the basic authentication there. And then on the client side, you would probably do this in the app.config file if you want to, but I've chosen to do this in the code file. What I'm doing is, I'll just stop the debugging there. I'm actually overriding this in the actual client code by setting the transport and the client credential type there to basic. Lastly, you will need to enable the HTTP authentication on your website, sorry, the basic HTTP authentication, and that's done in the authentication section. I've just enabled this basic HTTP authentication there. Okay, a summary for this sample. We're using basic authentication, and that's in order to maximize the client compatibility. We're using IIS to authenticate the actual client, so I'm using IIS 7 in this case. A couple of the security requirements. A Windows Communication Foundation client will not use basic authentication without a secure channel, so it won't send the equivalent of plain text passwords across an unsecure channel. If you're not using certificates from a certified certificate authority, you will need to override the certificate validation client side or generate your own certificate authority, which I've showed in the demo. Further resources, this is from one of the samples in the Windows Communication Foundation Security Guide that you can download in CodePlex. And the sample is from Chapter 13, but I'm using Windows accounts instead of the custom account provider.